During this segment, we will be multiplying and dividing real numbers. Let's see if we can discover some sign rules for multiplying real numbers. To do so, we'll depend on our knowledge of adding real numbers. For example, we want to know what is 3 times -2. Now, if you'll recall, multiplication is actually a shorthand notation for repeated add-ins. What does 3 times -2 mean? It means 3 add-ins of -2. So in other words, it does mean -2 plus -2 plus -2. Once again, this multiplication problem means 3 add-ins of -2. So it's -2 plus -2 plus -2. Well, we know how to do this. We know how to add real numbers. We're adding two numbers with the same sign. We add the absolute values and keep the sign. Plus -2. Again, we're adding two numbers with the same sign. We add the absolute values and keep the sign. So since -2 plus -2 plus -2 is -6, we then know that 3 times -2 is -6. This might lead us to believe that the product of a positive number and a negative number is a negative number, and that is true. We can do some similar work and come up with a rule for the product of two negative numbers, but it is true that the product of two negative numbers is a positive number. So let's review these sign rules for multiplication once again. The product of two numbers with different signs, such as this, is a negative number. And the product of two numbers with the same sign is a positive number. So keep that in mind as we multiply real numbers. And we will review this as we do multiply real numbers. Let's suppose we have -6 times +4. And it is important for you to realize that this is a multiplication problem. This is -6 times +4. So what is 6 times 4? 6 times 4 is 24. And what is the sign of this product? We're multiplying two numbers with different signs. So the product is negative. And so this is -24. Keep in mind your sign rules for multiplying. Let's suppose I have 2 times -1. Now, first of all, realize that this is a multiplication problem because later we will be mixing up addition, subtraction, multiplication, and division of real numbers. So notice this is multiplication. I'm multiplying a positive number times a negative number. So the product is negative, and 2 times 1 is 2. This product is -2. Let's suppose I have -5 times -10. Once again, make sure you understand that this is multiplication. I'm multiplying a negative number times a negative number, so the product is positive. 5 times 10 is 50, so this product is positive 50. Let's continue practicing. Let's look at the product of a few fractions. Suppose I have 2/3 times -4/9. Understand once again that this is multiplication. Once you understand that it's multiplication, what is the product of a positive number and a negative number? What is the product of two numbers with different signs? The product is a negative number, and then we worry about multiplying fractions. To multiply fractions, it's numerator times numerator over denominator times denominator. So this is negative. 2 times 4 is 8 over 3 times 9, which is 27. This can't be simplified, so our product is negative 8 over 27. Now, we can also have negative numbers raised to powers. We can have an exponential expression where the base is a negative number. Let's try the following. Let's suppose we have negative 2 in parentheses to the 4th power. Remember what that exponent means? It means we have 4 factors of negative 2. So let's go ahead and write that down. It's negative 2 times negative 2 times negative 2 times negative 2. 1, 2, 3, 4 factors of negative 2. Now let's multiply from left to right. What is negative 2 times negative 2? That is positive 4. So I still have times negative 2 times negative 2. And let's continue. 4 times 2 is 8. What is a positive number times a negative number? That is a negative product. So this is negative 8. And then I still have times negative 2. And then what's a negative number times a negative number? It is a positive product. 8 times 2 is 16. So this is positive 16. And negative 2, that negative number raised to the 4th power, is positive 16. Now compare this with something very similar, but suppose the negative 2 is not in parentheses. Suppose I have negative 2 to the 4th power. This is very, very important, and it's the following. Without parentheses, this exponent of 4 applies to 2 only. Make sure you make a note of this. Make sure you remember this. Without parentheses, the exponent, in this case of 4, applies to the base of 2 only. So only 2 is raised to the 4th power. You do rewrite that negative, but then it's 4 factors of 2. So it's negative. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, and this is negative 16. Very, very worthy of writing down and making sure you study this. All right, we're going to talk about dividing in just a moment, but before we do, let's make sure we talk about multiplying by 0. It is true that if, say, b is any real number, b times 0 is 0, and 0 times b is 0. So even with any real number, if one of the factors is 0, the product is 0. So for example, negative 7 times 0. We are multiplying. I'm multiplying a real number times 0. That product is 0. Now we're going to move to dividing, and before we move to dividing, let's talk about how we take the reciprocal of a real number. Let's look at the following. Reciprocals or multiplicative inverses. 2 numbers whose product is 1 are called reciprocals or multiplicative inverses of each other. So let's practice finding reciprocals. Let's find the reciprocal of 2/3. Remember, we are looking for a number that when multiplied by 2/3 is 1. Then those 2 numbers are reciprocals of each other by the definition. If I multiply 2/3 by 3 over 2, notice what happens. I have 6 over 6, and that is indeed 1. So the reciprocal of 2/3 is, just like you'd guess, 3 over 2. Reciprocal of 2/3, it's 3 over 2, and that is the reciprocal. Let's try a negative number. What is the reciprocal of negative 14? To find the reciprocal of negative 14, I'm looking for some number that when multiplied by negative 14 gives me a product of 1. If that happens, then I have reciprocals. Well, remember this can be thought of as negative 14 over 1. So notice if I multiply that by 1 over negative 14, I have negative 14 over negative 14, which is 1. So the reciprocal of negative 14 is 1 over negative 14, or I can write it as just negative 1 over 14. This is the reciprocal of that number. Now, why did we talk about reciprocals? So that we can now talk about division. What do we mean by the quotient of two numbers? Well, if A and B are real numbers and B is not 0, then A divided by B is equal to, this is just another way of writing it using fractional notation, A over B, which is equal to A times 1 over B. Now, what is so important about this quotient of two real numbers? Since we define division of real numbers in terms of multiplication, it means that the rules for multiplying, at least the sign rules for multiplying, are the same as the sign rules for dividing. Let's see what I mean. Multiplying and dividing real numbers, the product or quotient of two numbers with the same sign is a positive number. Then the product or quotient of two numbers with different signs is a negative. Once again, since we define division in terms of multiplication, the sign rules for multiplication and division of real numbers are the same. So let's divide. Here I have 18 divided by negative 2. Well, a positive number divided by a negative number gives a negative quotient, and 18 divided by 2 is 9. So 18 divided by negative 2 is negative 9. Let's continue dividing real numbers. What about negative 12 divided by negative 4? For this example, we are dividing two negative numbers. A negative divided by a negative gives a positive quotient. So the quotient is positive, and 12 divided by 4 is 3. So this result is 3. Let's look at, say, fractions. What is, say, negative 5/9 divided by negative 3/4? I have a negative fraction, a negative real number, divided by a negative fraction or a negative real number. What is a negative number divided by a negative number? It is a positive quotient. So the quotient is positive, so I'll simply write this as 5/9 times the reciprocal of 3/4, which is 4/3. And then this is 5 times 4, numerator times numerator, over denominator times denominator. That's how we multiply fractions. And 5 times 4 is 20 over 9 times 3, which is 27. And this is in simplest form. Now, by the way, I knew this quotient is positive because it's a negative number divided by a negative number, but if you'd like, you can write this as a negative number times the reciprocal of negative 3/4 is negative 4/3, but still a negative number times a negative number is a positive product. So the result is still 20 over 27. Let's suppose I have, say, 0 divided by -4. Suppose I want to simplify this expression, or suppose I want to divide. Now, think a moment about multiplication and division being opposite operations. If this is going to be some answer, it's going to be some answer or some number n, let's suppose, so that n times -4 is 0. Now, once again, just to remind you, let's suppose we have 12 divided by 3. Well, we know 12 divided by 3 is 4. Why? Because this number times this number is this number. So we're doing the same thing here. I'm looking for some number in so that that number times -4 gives a product of 0. You can call it n, you don't have to call it anything, but can you think of a number that when multiplied by -4 gives a product of 0? The answer is 0. 0 times -4 is 0, so this does simplify to 0. So if 0's in the numerator and you have some non-zero real number in the denominator, it simplifies to 0. Compare that with, say, 5 over 0. If this is to exist, it should equal a number that when multiplied by 0 gives a product of 5. Once again, can you think of a number that when multiplied by 0 gives a product of 5? The answer is there is no real number that when multiplied by 0 gives a product of 5. So that we say this is undefined. Let's go over these rules for division one more time. 0 as a divisor or dividend. The quotient of any non-zero real number and 0 is undefined. In symbols, if a is not equal to 0, a over 0 is undefined. Also, the quotient of 0 and any real number except 0 is 0. In symbols, if a is not equal to 0, 0 over a does equal 0. Now that we know how to multiply and divide real numbers, let's practice evaluating expressions. Now keep in mind order of operations. So let's evaluate this expression. This fraction bar serves as a grouping symbol, so we work above and below separately right now. If I start above the fraction bar, notice I have subtraction and then I have multiplication. What's higher in order of operations? Multiplication is. I know that this looks very good and you want to do it first, but remember order of operations. So once again, we multiply before we subtract. So this is 6 minus, and then we multiply 2 times -3, and that is -6. All right, let's do that again. Here below the fraction bar, this is subtraction and this is multiplication. What do we perform first? We perform the multiplication. So first I write down 4, I rewrite this negative sign, and then I have 3 times -2. 3 times -2 is -6. So -6. Now let's continue above and below the fraction bar. Here I have 6 minus a -6. Well, that's the same as 6 plus a +6, or simply 6. And then underneath the fraction bar, that's 4 minus a negative 10. That's the same as 4. Change the sign to addition. Change this second number to its opposite. And the opposite of negative 6 is positive 6, or simply 6, however you want to write it. So what is 6 plus a positive 6? Well, that's 6 plus 6, which is 12. In the denominator, 4 plus 6, that's 10. So this evaluates to 12 over 10, but notice this fraction can be simplified. There is a common factor of 2. 12 is 2 times 6. 10 is 2 times 5. And then we divide out that common factor of 2. Simplified, we have that expression evaluates to 6 over 5. Order of operations and how we operate on real numbers. This time, let's evaluate this algebraic expression given replacement values. So we replace the values. Here I have x squared plus y all over 3y. Now remember, that means 3 times y. So let's replace x with negative 5 and y with negative 3. Be very, very careful right here. This x is to be squared. So to ensure that negative 5 is actually squared, we do place negative 5 about, or we do place parentheses about negative 5. So there we have negative 5 quantity squared plus the y value is negative 3. And then let's not lose anything. This is 3 times y, or 3 times negative 3. And there we go. Now let's go ahead and evaluate. Let's work above and below the fraction bar. We're squaring, and then we have addition, so let's square first. What is negative 5 times negative 5? It is 25 plus negative 3. And then separately below the fraction bar, we have 3 times negative 3, which is negative 9. And then let's continue. I'll go across here. What is 25 plus negative 3? Adding two numbers with unlike signs, we subtract, and that is 22. 25 minus 3 is 22. Keep the sign of the number with a larger absolute value. It is positive 25, or simply 25. So this is 22 over negative 9. Now, you can leave it like this, or you can place the negative sign in front of the fraction. These two are equivalent. But this expression, given these replacement values, that is negative 22 over 9. A football team lost 4 yards on each of 3 consecutive plays. Represent the total loss as a product of signed numbers and find the total loss. All right, remember first we want to represent the total loss as a product of signed numbers. On each of 3 consecutive plays, there was a loss of 4 yards. So each of 3 consecutive plays, how can we represent a loss of 4 yards? We can represent that by the sign number negative 4. So the total loss, although the word total you usually think of addition, multiplication is a shortcut for addition of the same number. So total loss is this product, 3 times negative 4. And what is 3 times negative 4? That is negative 12. Now, what is then that loss? It is a total loss, a loss of 12 yards. Why is it a loss? Because our product is negative.